Hi, here's section 1.2 on types of data. So to begin with, the total population, that would be all of the subjects that you are going to be studying. So for example, if it was the United States, we're talking about 329 million people. Well, if you were to collect some numerical information from all of those people, that would be called a parameter. Talking to 329 million people takes quite a while, so perhaps you just want to get a sample. So you go out, randomly choose 1,500 people, collect numerical information, and from that sample, the numerical information is called a statistic. I actually remember it using alliteration. P is the beginning of population, P is the beginning of parameter. Sample starts with S, statistic starts with S. So what about the average age of Ordinal students? Which of the following is a statistic? So statistic means it comes from a sample. And we have these two symbols for the average. There's X bar, saying the average of a sample is 26.3. And then there's mu, which means the average of the whole population is 26.3. Since this question, I was asking for a statistic, S goes with sample, so which one is the sample? That would be this one. X bar is the sample information, or the sample statistic. Then with data, there's two main types, qualitative and quantitative. So this is referring to a quality. So for example, I used to have red hair. Well, some of it's sort of red, but anyway. And then there's quantity. So this would be an amount. So qualitative describes qualities. So for example, it could be somebody's name, their gender, their political party, the color of their eyes, things like that. Qualities. And then quantitative is going to be numerical, so it's a quantity. And with that, there's two main types. So discrete data is countable. So quantitative refers to numbers, and then within numbers, there's two main types. So discrete are things that you can count. So if you start the statement off, the number of that is going to be discrete, it's countable. So this family has 2 parents and 4 children. You can count the parents, you can count the children. Then there's continuous data, and this is for measurements. So for things like a person's height, you can measure that. With their weight, you could measure that. The weight of their car, you could measure that. How fast their car is driving, you can measure that. And with measurements, they can be extremely accurate. If you have a very accurate way to measure somebody, you could find out they're 67.883 inches tall. One way to tell the difference between discrete and countable is with discrete, there would be one object and then the next object, and there would be nothing in between. So for example, this right here could say 4 children, or perhaps it could say 5 children. But for them to say, oh, we're 2 parents and we have 4.17736 children, that doesn't make sense. It's either 4 or it's 5. There's nothing in between. With continuous, it continues. So one person could say they're 67 inches tall, the other one's 68. If you accurately measure, is it possible there could be something in between 67 and 68 inches tall? The answer is yes. Like, for example, 67.883. And now on to the last idea, levels of measurement. So this is not necessarily saying numerical, not numerical, we're just starting over. Here's another way to look at types of information. And I remember it by using the word noir, which means black in French, but it's the letters that I need, N-O-I-R. So these start from the most basic, which have the least amount of information, and then they build up from there. So nominal is the most basic. So for example, somebody's name, Greg, not a lot of information there. It's just Greg. Labels such as gender. Also, there's so little information that they can't be put in order. So for example, with gender, he, she, they, I just happen to say it that way, but that doesn't mean it goes in order, he, she, and then they. So there is no order. Someone's, the color of their hair, it's not like people with red hair go first, though they should, but they don't, believe me. Next up, so we're basically taking the nominal information and now build it up just a little bit. So it includes names and labels, but they could be put in order. The example I like to use is grades in a class, A, B, C, D, F. So first of all, they're just names. A is a name, B is a name or a label, but there is an inherent order. Would you rather have an A in the class or would you rather have an F? Well, first I'd like to have an A. If I can't do that, second I'd like to have a B, etc. So there is some inherent order there. But if I subtract them, if I take an A minus a D, that doesn't really mean anything. I can't even get an answer for that. So that's ordinal. Now on to the I, which is for interval. So we're basically building up. This has more information. So you can put them in order and you can subtract them, but there is no zero or natural starting point. I like to use years. So if you go from 2014 back to 1990, that means that's 24-year gap. So if somebody was born in 1990 and then you wait until 2014, they were 24 years old then. But there is no natural starting point. So you could count back, say, well, there's 1990, before that there was 1980, before that, etc. Before that there was the year 700, before that the year 600. Eventually you get to a zero. But that zero is rather arbitrary because that's not the starting point of time. That's just some 2,000, little over 2,000 years ago. So there is no actual zero or starting point. And then finally, the one that has most information, that's ratio. So it includes the interval information, but it also has a natural zero point. So for example, the distance between two objects. So you could find out how far away one object is from you, how far away the other object is. When you subtract those numbers, that's the distance between the two objects. Now, if those two objects were suddenly right here in your hand, then the distance is zero. And that would actually be a possibility. If you're holding it, how far away is it from you? Zero. So that has a natural starting point. Well, that's section 1.2. Have a good time, and I'll see you soon.